Welcome to the homework help video for module 15.1, and we are going to be working with logarithms. Now, logarithms are the inverse of exponentials. That's their definition, So go ahead and take a look at number 5, pause and try it. So on this one, we are asked to write each exponential equation in logarithmic form. So easy. We're asked, in this statement, we're saying 5 to the power of 3 is 125. In other words, if I take 3 5s and I multiply them together, I get 125. The logarithmic form of this would be log base 5, which is asking the question, how many 5s do I need to multiply together in order to get 125? So log base 5 of 125 is going to be equal to 3. That's not a very good equal sign. That's a little better. So this is rewriting the original equation in logarithmic form. It's just asking a slightly different question. How many of this number do you need to multiply together to get that number? And the answer is 3. I'm going to be doing the odds in this homework help video, but do note that I would like you to do 6 and 10 on your own. I'll take a look at those. And number 6 is a bit tricky. It does have a negative exponent, but it's the same idea. So number 7, we have 3 to the power of m equals n. So I want to know, how many 3's do you have to multiply together in order to get n, whatever n is? And our answer is m. So I have to multiply m 3's together in order to get n. So maybe n is 3, in which case you only need 1. Maybe n is 9, in which case you would need 2 for m, right? So that's our logarithmic form. Number 9, we are doing the inverse. We already have it in logarithmic form. We want to write this in exponential form. So go ahead and pause and try number 9. And on this one, we see our base is 6, so it will be 6. And, we only have a couple of options here. Is it 6 to the power of 1,296 is 4, or is it 6 to the power of 4 is 1,296? I think I know my answer. You can always double check. 6 times 6 is 36. Times 6 again is a big old number. Times 6 again is 1,296. Don't believe me? Put it in the calculator. Here's number 11. Go ahead and pause and try it. So on this one, we have a base of 8. And we want to know 8 to this power should give us x. 8 to the power of y should give us x. Because the logarithmic is asking how many 8's do I need to multiply together in order to get this number x. And in the exponential form, we're saying, well, y 8's, that's how many 8's we need to multiply together in order to get x. Okay, so there we go. A bit tricky. We'll get there though. Remember, we'll have plenty of practice, plenty of opportunities to get good at this stuff. So numbers 6 and 10 are for you to go ahead and do on your own. I'll get some feedback to you. Let's move on. Number 13. On this one, we need to find a couple, so we are given a function rather, f of x equals log base 3 of x. And we need to find, well, what if we plug in 243 for x? What if we plug in 1/27th? And what if we plug in the square root of 27? So I'm going to do a couple of these, and I want you to do the remaining one. So I think I will do this one and this one. So let's take a look at those problems. You will be left to do this one right here. All right, so if f of x equals log base 3 of x, find f of 243. So f of 243 will look like that. And it's asking the question, how many 3's do I need to multiply together to give me 243? Now we could just do this, right? We could just figure out how many 3's is required. However, if we want to write our work out in a more, what's the word I'm looking for? Mathematical, logical fashion, then our work really should look like this. because that's really what we're asking. 3 to what power is 243? That's what a logarithm base 3 is asking. So I'm going to write my work like this, and you've seen this in the notes, right? So I want to rewrite 243 as 3 to some exponent. So that's going to be my answer. Whatever exponent I can get here, that's going to be my answer. So 3 times itself, how many times gives us 243? Well, 3 times 3, that's 2 3s, is 9 times another 3, that's 3 for those of you keeping track, is 27 times another 3, we're up to 4 now, is 81 times another 3, that's 5, that's 243. So 3 to the power of x equals 3 to the power of 5, so x must equal 5. All right, so it's tricky. It's a good one, especially when you have fractions or even worse, square roots, which is why I was going to take on the square root on this problem. So let's go ahead and give that one a shot. F of root 27. So if you think you're up to it, pause and try f of root 27. Okay, so once again, I'm going to rewrite this as 3 to what power is equal to root 27. My goal, however, doesn't change. I want to be able to say that this is 3 to some power equals 3 to a power, so I can figure out what power is that. So I can't do it in one step, I think. I think this is one where I'm going to have to take it multiple steps at a time. So the square root of 27, I'm going to call that 27 to the power of 1/2. Okay, so no more root, now it's an exponent, but I still don't have the same base, which is a problem that I need to fix. Okay, so I know it's the 1/2 power rather than a square root. Next step. 27 is a power of 3, so I can say 3 to some power to the power of 1/2, right? So I just need to find 27 to what, 3 to what power is 27? So 3 times 3 is 9 times 3 again is 27, and so that was a power of 3. So I changed 27 into 3 to the 3rd power. Just a little note. There we go. So that's what I did. I replaced 27 with 3 to the 3rd. And the reason I did that is because I want these bases to match. If they don't match, then I can't solve this equation. So, final step. This is going to be 3 to the power of 3 over 2, which means that x is 3 over 2. All right, so that was fun. I like that problem. You are going to be left to do 1 over 27. I think, yep, the number 15, yeah, that's 15. Number 15 also has one of these fractional ones, so I will do the fractional one on that one. So if you're still not quite sure how you would handle the fraction, don't worry, I will be doing a similar problem on 15. So you might want to check out that one first and then come back and try 1/27. Okay, so speaking of 15, let's go ahead and move on to that one. Number 15. This has a base of 1/4, so log base 1/4 of x. That's our function. We need to find f of 1/64. So I will be doing this one and that one. I will leave that one for you to do. So let's give it a shot. All right, I brain farted. What am I doing? Okay, f of, that's right, f of 1/64. All right, so that is how we'd write that in logarithmic form. And what I want to know is 1/4, how many 1/4 do I need to multiply to get me 1/64? So that's going to be 1/4, parentheses, because it's a fraction, to the power of x equals 1 over 64. So what I'd like to do is change 1 over 64 into 1/4. So some exponent, right? So luckily, I start with a fraction, and this one's already a fraction, so cool, that saves me some trouble. I'm going to have 1/4 to the power of x equals 1/4 to what power? So 1/4 times 1/4 is 1/16, times 1/4 again is going to be 1/64. So this is 1/4 to the power of 3. 1 over 64 is the same as 1/4 to the power of 3. So cool. That means that x is 3. So that's my answer. As for the next one, 256, pause and try that one. So this one is a good problem. It's taking a fraction and turning it back into a whole number. And it's going to look like this. Whoops, where did that equal sign come from? Let's see. So this is asking 1/4 to what power is equal to 256. So cool. So first, I think what I'm going to try to do is turn this into a power of 4. And then I'm going to use the negative exponent property to flip it over and call it 1/4. Right? So if I have a whole number and I want to change it into a fraction using an exponent property, then I'm going to be using the negative exponent property. So like I said, I think my goal, I'm going to start by turning 256 into a power of 4. Hopefully it is a power of 4. Spoiler alert, it is. So let's give that a shot. All right, 4 times itself, how many times equals 256? Well, 4 times 4 is 16, times 4 again is 64, times 4 again, for those of you keeping track, that was 4 of them, does in fact equal 256. Then, like I said, if I have a whole number and I want to make it a fraction, like flip that over, I can do that using the negative exponent property. Usually we use the negative exponent property to do the opposite of what we're doing right now. We take a negative exponent and change it into a positive one, but the same is true in reverse. So you can flip something, you can find the reciprocal of something to change an exponent from positive back into negative, and occasionally we want to do that to solve an equation such as this one. So my answer is going to be that. So therefore x equals -4. All right, I know I wasn't showing my face on this one, but that one put a smile on my face. I like that problem. So I circled the ones that you have to do. I believe those were 6, 10, and then let's see, 1/27 for number 13, and then this one, the cube root of 16 for number 15 here. Okay, so good luck on those ones. I hope this homework help video was useful. I will get some feedback to you on those ones that I'm asking you to do alone. And yeah, I'll see you again next time. Bye-bye.